China is one of the main carbon production countries in the world, with its northeast regions producing the most greenhouse gases. That is because the region's winter lasts 6 months long. To survive, people rely on boilers heated by coal. Scholars and researchers have long since looked for an eco-friendly alternative to coal. And now we introduce you to a system that relies on underground sewage to help regulate temperatures. Summer in China's northeastern city of Harbin, the provincial capital of Heilongjiang province, is enjoyable but short. Winter begins in October, covering the region in thick layers of snow that last until the next March.
Most heating in Harbin is provided by boilers, which provide heating for the whole district. For every square meter of area being heated in winter, 40 kilos of coal is consumed over the course of the winter. As the coal burns, the carbon dioxide produced is multiplied by 3, which means 120 kilos are discharged for every square meter. There's no way to reduce carbon emissions with these methods.
For every kilo of coal burned, 3 kilos of carbon dioxide is released into the air. With limited supplies of natural energy source in the world, how will northeast China endure its frigid winter while still remaining environmentally friendly?
Solar energy applications in heating and cooling run into the problem of the limited availability of the sun. Sometimes the sun's out, sometimes it isn't. Storing the heat and electricity is a problem too, so there are many bottlenecks. Now wind power, it works great in the northwest, it generates electricity too, but to heat the whole vast north depletes a lot of energy. So what other non-fossil fuel can we use? It's the heat that is everywhere in our environment.
Energy exists everywhere, in the air, earth and water, all of which can theoretically be used to regulate temperatures in our dwellings and make our life comfortable. In northeast China, Professor Sun says sewage holds the key.
Harbin's winter dips 20 to 30 degrees Celsius below zero, but sewage remains around 12 to 16 degrees Celsius. That'd make a warm winter. In summer it heats up to 30-something, but the sewage stays around 20 degrees. So in summer it's a cooling source, and in winter it's a heat source.
Statistics show that every year Harbin discharges 900,000 tons of sewage, while the whole of China discharges 70 billion tons. The sewage accounts for 40% of a city's background heat. So how can that energy be extracted? This is where heat pump and refrigeration cycle come into play, based on the same principle that works our refrigerators, air conditioners and heaters. A heat pump uses a substance known as a refrigerant, which has unique evaporating and condensing properties that makes it useful to manipulate temperatures. When the refrigerant of an air conditioning is compressed by its compressor, it becomes a very hot gas. Once this heat is allowed to dissipate and the pressure is reduced, the refrigerant becomes cold, which can then draw heat out from surrounding air, say a room, and so successfully lowers the room's temperatures. It is through this continuous cycle of compression via condenser and expansion, by a special expansion valve, that heat can be dissipated or absorbed. The refrigerant is then recycled back into the compressor, and the room temperature is controlled.
In this circulatory system, we have a high-temperature component and a low-temperature one. I can channel my pipe through to extract the heat for heating or to extract the cold for cooling purpose.
With increasingly limited conventional fossil fuels, humans must reevaluate our energy usage policy and discover new reusable sources. Many cities in China, besides Harbin, have already employed these green heating and air conditioning units in hotels or commercial buildings. Though sewage may be wastewater, put into the right use, it can still serve a great purpose.
Previously, we introduced you to the eco-friendly heating, ventilating and air conditioning system designed by the Harbin Institute of Technology, or HIT, in China's northern Heilongjiang province, which uses sewage as a heat source and a heat sink. However, the system must have access to large amount of water at any given time. The problem is that sewage contains a lot of solid waste, and if it is not filtered, the system clogs up. Conventional water treatment and filtration are far too costly. Thus, HIT has designed their own self-cleaning filtration system.
Situated by the Songhua River in Heilongjiang Province's capital of Harbin, this four-star hotel has a hidden secret. In 2003, it decided to forsake traditional coal-fired boiler heaters and installed a greener HVAC, developed by the Harbin Institute of Technology.
Oh, this heating system can keep room temperature above 20-some degrees Celsius. It's worth every penny. Back in 2003, when we had it installed, we estimated a 4-year return on investment. But now that coal prices have shot up, we can recover the cost of the system within a year.
In running a business, every penny counts. Using traditional coal-fired boilers, the 160-room hotel would need to purchase 3,000 tons of coal a year for heating. With current coal prices at about $100 per ton, heating costs would be about $300,000 per year, producing about 9,000 tons of carbon dioxide. However, the hotel's current green HVAC is heated by the city's sewage and does not burn anything or produce any ash or smoke. Research shows, in comparison to the two most common heating systems, this design outperforms the others by nearly 50%.
In other systems, for every unit of energy we consume, a unit of heat is generated. It's a 1-to-1 ratio. But using this heat pump technology, for every unit of energy we put in, we can retrieve 3 or 4 units of heat. Why? Because we are extracting heat from air, water, namely our environment.
But for this HVAC system to utilize raw sewage, clogging becomes a big problem.
In sewage, besides sand and rocks, there are organic materials like leaves, vegetables, animal waste, plastic bottles, medical waste, basically just about anything. To extract heat from such water, I need to use a heat exchanger, but allowing unfiltered water directly into the system clogs up the pipe immediately.
To heat 100,000 square meters requires 1,000 tons of wastewater. If 0.3% of the water contains particles, then that translates to 50 kilos of solid waste entering the system per minute.
In my lab, I use a filter with 4mm openings and unfiltered sewage. Within 40 seconds, the filter was completely clogged. So what kind of filter we use is not the answer.
It is not about what kind of filter should be used, but about how one filters. Thus, this self-cleaning filtration system was developed.
The filter inside rotates 10 times per minute, meaning it takes 6 seconds to rotate once. Each mouth of the filter will remain open for 4 seconds to receive water, and about 1 second where used water washes through, thus cleaning any debris clogging up the system.
Such ingenious designs give life to the green HVAC system. Extracting heat from sewage is a win-win solution for both the environment and one's pocketbook.
Next, we continue our series on exploring new energy conservation methods in China's Harbin. To battle the region's 6-month-long winter, one community that was built 20 years ago incorporates many simple yet effective heat conservation methods that still works even today. Yet, loss of heat through windows remains a big problem. For the solution, we head back to Taiwan to see how a professor at National Taiwan University of Science and Technology has formulated a next-generation window that not only insulates but also generates power as well.
This is the Songsan housing complex in the city of Harbin, Heilongjiang Province. The 20-year-old community is the oldest energy-friendly community in northeast China.
The community sits on a plot of land about 180,000 square meters in area. It fits the criteria for the first stage of energy conservation. Between the walls is insulating rock wool.
The community incorporates many ingenious energy conservation designs that are not costly. For example, the north-facing doors are designed to open against the winter wind to minimize heat loss.
When you enter the complex, there's another door inside to open once you close the first door. This prevents cold winter air from entering directly.
All the buildings here face south to maximize heating from the
Even in the coldest of Harbin's winters, houses here can remain around 18 degrees Celsius above zero only by relying on the sun's heat.
Though large windows provide ample lighting, they are not energy efficient. Given the same area, a window loses 5 times more energy compared to a wall. And thus there's a building code here, specifying window-to-wall ratios.
The window-to-wall ratio should be 0.3. That means windows should not take up more than 30% of a wall. The heat transfer coefficient should be brought down from 2.0 to 1.8 as well.
The lower the heat transfer coefficient, the better the thermal insulation, thus keeping homes warm in winter and cool in summer.
This is the worst window. Look, the figure is 80-something, whether it's infrared or UV light. Here the infrared is 61 and UV is 76, so it's just tricking you to think it's safe. Now this UV is 0 and IR is 4. This basically cuts off all UV and IR light.
Currently, the research for the world's next generation of energy-saving glass is being done right here in Taiwan, and Professor Yang Jinghuai is a lead researcher in the area. The glass he formulated has a layer of photovoltaic film, which can transform 70% of the sun's ray into electricity. Another layer of insulation film inside reflects the remaining UV and infrared light out for absorption.
A square meter of this can generate 90 watts. What does this mean? A typical energy-saving light bulb uses about 20 watts, so a panel of this can light 5 of these light bulbs.
This new invention can reduce air conditioning costs by half in summer and heating costs by 1/3 in winter. How well does this new glass insulate? Let's do a test. By using a 500-watt heat lamp as a heat source, the thermometer behind a regular glass keeps on rising, while the one behind the new glass hardly rises at all.
In a cold environment, say 5 below zero outside, the inside will still be about 5 degrees, so there will be a 10 degrees Celsius variance. In a hot environment, that figure increases to about 15 degrees. In our experiment, we've shown a temperature difference of 15 degrees at noontime.
The effectiveness of this new glass is heavily dependent on the angles at which it is placed.
Set on a slanted roof, when the light is perpendicular to the sun, it will function at 100%. However, if it's set like a window, which means it's not at a perfect angle to the sun, the efficiency will decrease by about 80%. On the northern hemisphere, the glass has to face south. On the south, it has to face north. Why? Because the way the glass is exposed to the sun from 8 in the morning till 5 in the afternoon.
The temperature outside is kept from interfering with the room temperature. Thus, this new glass will work in winter as well. But will this glass block out more than it has to?
If the sun is too bright, we actually need to reduce the shine. But the photovoltaic film in the glass can cut away the sun's intensity, and you can still work comfortably inside without the need to turn on the light.
This new glass will lose only about 1% of its efficiency every year. Cost-wise, a full return on investment for this green technology is expected to be between 4 to 5 years. It certainly is something worthy of all our attention in our search for a better tomorrow.